Hello, my name is Jani Kaskinen. I'm Senior Principal at AFRY Management Consulting. Thank you for joining our webinar around digitalization and precision forestry. With me, I have Jussi Rasinmäki from Simosol, who will introduce himself. My background is in the ICT industry, mainly in the software side, ranging from financial applications to travel applications, and also now for the recent years, forestry applications.
And hello on my behalf too. Yes, as Jani mentioned, my name is Jussi. I'm CEO of Simosol and also one of the founders of the company. My background is in forestry, but more specifically in putting IT and forestry together.
All right, let's get into the topic. So today's topic, we are talking about the smart forestry, which is our concept and the working name around digital enablers for precision forestry. We operate as experts in the management consultancy, but also with a wide range of partners who have different kind of digital solutions around this area. And the area is quite large, so this first session is really to go around in a high level all the topics that we are covering. On the following webinars, we're going to dig into each individual in more detail and looking at different options and technologies around it. We talk about why this is important for the industry or why it makes sense to do it or not. We'll look at the traditional ways of operating and the smart forestry way of operating. And then cover, again, somewhat high level, the digital inventory side, the advanced simulation and optimization, and then the supply chain visibility. And then discuss a little bit about the roadmap and how companies can achieve that precision forestry ideal outcome for their company. Starting on the big picture, smart forestry covers kind of the forest side and operations, the analytics, planning, harvesting and transport, and the processing side. Everything kind of starts with the tree-level digital inventory and monitoring. When talking about the precision forestry, the digital inventory is a key factor. Everything kind of starts from there and ends there. With that, monitoring the pest and disease and other damages, predictive analytics, site-specific management, simulation, optimization, and so on. And we're going to discuss also around these topics with Jussi, so we don't make this as a lecture, but kind of try to open up a different ways of looking at these different things. So first of all, when talking about the tree level inventory, Jussi, I know that at this point the technologies have been too expensive to kind of achieve that, and also it's been seen as a not so necessary, potentially different in a plantation environment or Nordic forests. How do you see the options today, and why would it be important?
Well, I would say that the technology has advanced far enough for it to be a realistic option already now. But it's not at the level where if we only purely consider the inventory as a cost item in the operations, that it would be necessarily very competitive method for measuring the standing stock on its own. But then when we put it into a bigger picture like here, the story changes quite a bit, because it all boils down to how accurate data are you able to feed into your system to then extract value of that data later on, and this is where I see it's kind of three-level digital inventory as a game changer.
What would you say typically? I know there's a big range, but what would you say typical accuracy is on the, let's say, traditional inventory methods?
There is a kind of fundamental difference also for the accuracy, in the sense that in the traditional inventories we are not measuring individual trees, we are measuring groups of trees and try to derive attributes, characterize this group of trees, whereas here it is really about measuring the individual tree attributes and then deriving the kind of causal level information about the standing stock from those individual trees. So it's not even we are not talking about the same inventory here, so it's kind of hard to compare the accuracy. But I would say that if we then talk about this kind of stand or compartment level attributes, we can easily kind of at least half the errors in that at that level.
Right. And when we talk about the site-specific management, I know the all traditional methods are also in a compartment or stand level kind of measurements. What's the difference in a site-specific management in a kind of precision forestry environment?
Yes, that's the other kind of game changer aspect of this, is because the traditionally, to some, making some simplifications here, of course, but kind of simplified said, the traditional inventory happens on predefined aerial units. We have the management units, the compartments defined prior to the inventory, and then we try to get the standing stock attributes for those. Whereas if the target for the inventory is a single tree, then actually part of the inventory process and part of the inventory problem is to create the management units. And here we can really kind of start to think about and talk about site-specific management. Because we can kind of dynamically delineate the management units based on what we see from the trees.
Right. And again, it comes down to accurate inventory data. And I think overall, when talking about the inventory and to different, typically a major lead customers that we have, there is a certain ways that it's been done for quite some time, and changing that, well, it's for sure more expensive. So it's kind of how do you justify that? And I think that's why we take the more holistic view on the whole topic, because there is tons of technologies on all of these areas at the moment. So when it comes to, let's say, forest operations optimization, there's certainly a good technologies around that. When it comes to transport, there is a good technologies around that. But somehow they don't connect or give the full potential of the value, mainly because the source information is not that accurate. And we can discuss a little bit about those topics as well. But I think it's a fascinating environment when I came to or moved to a forestry side, and yeah, there's a lot of advanced technologies around, but then the source data is a bit of a problem. And coming from the, let's say, for example, hotel booking industry, it would be like, okay, we optimize the route for you to book a hotel, search and find and book a hotel, but we're not quite sure whether it's available or not. So it was kind of difficult question, and I think I've been around this topic since then, and this whole picture has kind of clarified, and the several sessions that we've had, also with Jussi, with the customer organizations, it all kind of starts making sense. So it's available, but you really need to connect the dots. Talking about the predictive analytics, could you Jussi open up a little bit what we talk about here?
That's one of the kind of I would say, missed opportunities so far within the forestry sector, because the kind of usual practice is that you make an inventory, you use that inventory data as long as you then make the next inventory, and then you start using the next inventory data. If we are thinking that, well, so far we've been talking about this kind of digital inventory at a very fine spatial units, very, very detailed measurement of individual trees, but it can also be in a time dimension, this frequency, because this technology enables us to do that, and that opens the kind of the floodgates for utilizing the data better. So if we have a frequent inventory, we can then start building up layers of inventory data and kind of couple that back to the simulation and optimization aspects of this planning, and build this kind of learning cycle from inventory to what we then utilize the data for, and improve then those parts as well. So it kind of serves as a dual purpose of training and learning for the further steps in the supply chain, and providing more accurate starting point for the planning.
Yeah, and you mentioned the frequency there. I guess the traditional model is to go and measure let's say, correct me if I'm wrong, 1% of the forest assets. And then you utilize kind of those metrics across the whole asset side. There will be variation for sure. And I think in the same way, going from, let's say, stand or compartment level to a site-specific management, there's a big difference as well. Or let's say it's more accurate and kind of core for the precision forestry. Everything shall lead to a yield increase, I would assume, on the forest side, right? Can you talk about that a little bit, especially in a kind of, again, I think in a plantation environment that is quite easy to understand, that the cycles are fairly short. You need a higher frequency, but what about the northern forests?
Yeah, it's about it's actually the same phenomenon, of course. I mean, trees are trees, but they just grow in a little bit different pattern. But for plantations, I would say it's about, in plantations we are controlling what goes into the plantation. We know pretty much what's the potential intermaterial that goes into plantations. Then it's a question about timing and planning the management so that this potential is met. And then here we have a clear link then to this site-specific management and predictive analytics, so kind of fine-tuning as we go, not doing things by the book, but learning what we are seeing and changing based on that. But it is actually the same also in the northern latitudes and boreal forest, for example. There the plant material that is in the forest is not so tightly controlled. To some degree it is with the planted material, but I mean there is also always a natural aspect to it, or natural part of the plants. But it's still the same phenomenon, I would say, in that sense, that again it is about the accuracy of and the timing, the operations accuracy of making right type of operation, and this requires knowing exactly what is there, and also kind of site-specific management. So really kind of forming the management units based on what you see in the forest, and then leading from that to the more accurate management and timing. And it is actually shown that this can lead to a kind of yield losses, in the sense that if you time, for example, a thinning operation in a boreal forest based on incorrect tree species composition information, you are actually losing quite a lot because the timing is wrong for the thinning.
Right. So some of the differences between the traditional way and smart forestry and understanding that all things are not equal. Some companies are very advanced in some areas and some on the other ones. So going from, first of all, to the from manual planting to the mechanized planting and site-specific clonal material, I think the strong link to R&D is very important factor here. Can you talk a little bit about that? Let's take on let's say plantation environment first, or similarities.
Yeah, I would say in some cases it can be that the potential is definitely there due to the R&D activities. So your starting point is very good, but then unless you are able to track what is where and how is it doing, and then again coming to this pretty much to the second point, then adjusting to the site-specific management, it may be that you are not reaching the full potential. So here I would say this kind of mechanized planting, of course, one word for it is higher, or two words, higher efficiency, of course, but then also this kind of trackability or visibility of and keeping information of kind of full flow of information from one step to other in order to be able to guarantee that the potential is reached. That's the other aspect of this.
Right, and I guess there's technologies again around the mechanized planting that would then allow to mark planting spots or the frequency and so on to further kind of enhance the digital inventory side.
Yes.
Standardized silviculture treatments, for example, fertilization. I would say if it's based on the broadside classification, it's kind of applied everywhere in an equal way. For sure, in some areas gets it for no reason, and some areas for very good reason. But I guess there's somewhat significant saving potential also in chemicals and treatments.
Yeah, I would expect so. I mean, what I usually call it, or make the contrast between management by the book, so very general guidelines, and this is how the management is done, and then management by the need, kind of deriving the management also partially, of course, from the book, because that has the kind of general outlay of how management should be done, but then adjusting it based on what you have is what I would say is it is the kind of requirement for reaching this kind of savings.
Right. And on the damage monitoring, of course, if you are doing digital inventory in a high frequency, it kind of comes with the same package, right? But in cases where the inventory cycle is longer, like in northern forests, how would you kind of approach the damage monitoring in those cases?
Yeah, the kind of tropical plantation case is easier for this, because you kind of get this kind of damage monitoring almost like for free if you go for this frequent cycle of inventories. But then, and so that's a definite plus in those latitudes. But then northern latitudes, yeah, then it would be a combination of different approaches. So one outcome of the inventory, again, of course, is this very accurate level control for possible problems. But then in the kind of before the next inventory cycle, in the meantime, then we can use coarser information sources like satellite images to do the monitoring between the inventories. That's one possibility. And again, this is kind of technologically enabled now, because we have more and more and more frequent, also in temporarily more frequent access to satellite images. So this is again something that is now completely feasible, which was almost like, let's say, 5 years ago, still was not quite really feasible.
Yes, and there's some very exciting new satellite technologies that are available today already. However, let's try to differ from starting advertising in the first first webinar. But yeah, there's quite a few options around that area with the let's say enough frequency. There's also satellites, obviously, but there's also long flying drone technologies, right?
Yes, the drone technology is also kind of one of the technologies which is going through a very kind of rapid pace of development, and for sure we haven't seen, not even, I don't know, well, we've seen the start of it, but definitely it's something that is very rapidly evolving.
Yep, sorry, my screen started refreshing rapidly. I'm correcting that, but yeah, so they are kind of balloon-based drones. How long can they be up at one go?
They can be there. There are different. I think there are different options. Some are almost like semi-permanent ones, which typically then, of course, fly quite a bit higher, or then days to weeks, I would say.
Right, which would make sense, and I think that's why some of the companies are investigating or utilizing those for forest fires and other damage controls. On the operational side, I think that's one overall big topic, and as I mentioned, there's a lot of technologies already in place and widely used to optimize the operations. But I guess one of the aspects or problems there is that there is in a typical environment there is a contractor-based operations, one portion, and then the other portion is kind of own fleet. And one problem with that overall fleet is that there is many different brand of machines, but also many different age group of machines. Some of the new, as an example, harvesters can provide so much information that we don't necessarily even know today what to use it for, compared to some environments where there's no technology at all within the machine. That causes a obvious sub-optimization, so that you can get gain visibility to some and then some not. So there are technologies to overcome this as well, correct?
Yeah, I mean, here we can get to the one of the buzzwords of today, which is kind of the IoT technology is also one front which is advancing rapidly, and I would say it's nowadays entirely feasible to bring the sensors to the old machines. So basically sensorize the machines in a way that in a kind of very light manner, in that sense that there's no need to really connect the sensors to the machine itself as such, but just to bring the sensors to the machine in an IoT device, which can then interact with other devices in the neighborhood, and then kind of bring the data further in the chain to the eventually to the back office. So yeah, this
Right,
kind of
right.
one of the recent technological advances is this kind of sensorize the whole world.
Yes, I think, yeah, internet of everything. Yeah, and that then obviously gives an opportunities to optimize that supply chain a bit better.
Yeah, and give I think the key word is visibility, because this is what is in many cases now lacking. That in principle we know what is happening in the forest, but in practice we don't really know it. Maybe even only when the wood arrives to the mill gate is maybe the next point when we know what is really happening. So it's to first give the visibility, and if you have the visibility and the data for the visibility, then it opens up the possibility for optimization, of course. But if you don't know what is happening and what's going where, there's simply no way to optimize it.
Yeah, and you're also oblivious of potential problems or bottlenecks for that reason. Yeah, that makes sense. And you've been obviously heavily involved for years now in the optimization and simulation world of forests. How do you see that kind of evolving with the more accurate digital inventory data? What kind of problems does it solve, and how big are those problems have been?
Well, I would say it's kind of a compounding effect or multiplying effect in that sense that when you put the data into a planning system that first simulates we are talking about looking into the future here. So right. You need to know what happens in the what you have now, and then what happens in the future. And with trees, of course, they are dynamic, so they don't stay the same. So they grow over time. So that's what we want to address when we are doing optimization for the forest asset itself. And there are two aspects to it. It's the accuracy of data that you put in, of course. So it's the old saying, rubbish in, rubbish out. So that's kind of clear connection between what goes in and what goes out. But then we, of course, also have the models, the prediction models that are used in the simulation that describe the growth of the trees. And this is another aspect that the new kind of inventory data that can help in how accurate it is. Well, then the better the models work with, the more accurate the data is. But also going back to this predictive analytics, that we can train then our predictions if we have more frequent data, and then that way improve the accuracy of this optimization.
Right. And then naturally, when talking about the kind of wide solution area and solution set, also it's fair to say that the enterprise customers do have an existing IT infrastructure which consists hundreds of different programs. Some of them connected and some of them not. But I guess one key aspect on precision forestry is that the related software systems are connected.
Yeah, that's how you can then kind of harvest the value in individual steps, making sure that the data really travels through the system. So basically what we are talking about here is ideally is kind of building a digital twin of the whole supply chain from the forest to the mill gates, and then have the kind of individual components in that digital twin that are aware of each other and can exchange data, so that again this kind of multiplying effect would then be realized, because first we know better what is there, we are better at predicting what will be there, and then that all comes to the actual operations, that when we are, for example, planning a harvest at some specific date, belays at some specific date, we are actually fairly certain of what is there at that point in time, and how much of it can then go, for example, to the mill.
Right, exactly.
So if you can do this digitally first before doing it in real life, and have a kind of good hit rate for the results, then the less trucks will be traveling needlessly into a place where we thought something would be, but actually isn't.
Yeah, exactly. So talking about why, and kind of leading into this is kind of my favorite topic is on the digital inventory side, and kind of circles back always to it. And kind of answering the question why should or shouldn't you do a more accurate digital inventory, you have to look at the whole supply chain, right? And there's metrics. Metrics are very individual for individual companies. So I'm not saying that one size fits all. But looking at some of them, for example, the improved plantation situation awareness and planning accuracy to get better damage prevention and preventing yield losses. I know it's hard to put any numbers around that, but I still ask you to put some numbers around that. So what would you say that the good and accurate digital inventory measurement would mean to a damage prevention and yield losses?
Yeah, it's that is the kind of one of the hardest questions to put really numbers on it, because damages are kind of, you are risking of losing your whole asset if a pest outbreak, for example, is able to gain really force. So it's a kind of on off, in some cases even on off situation. So it's some cases it's a gradual improvement, can be gradual improvement, but in those cases on off, it's like you either have it all or then you lose it all.
Yeah.
And here we are talking for damage prevention. I would say that we are really talking about this kind of a added bonus of higher frequency of inventories. That would be, or then the added the gain from really executing frequent monitoring separately. Then that's what you stand to gain.
Yeah. No, and exactly, and I think those are for individual companies to talk with. I guess it depends on the areas, and it depends on the frequency and type of damages that they have. The number may be big or small. But also related to that is that finding out about the damage later on in a process causes a lot of inefficiencies as well. For example, you have sent the harvesting crew to a certain spot expecting that there is a certain amount of timber to be harvested, and they realize on site that there is some damages. So the whole kind of planning cycle starts again. So it's not only preventing the yield losses, but related, let's say, operational inefficiencies.
Yes.
Another thing about the site-specific management and related predictive analytics, and I would say that the site-specific management, as we talked earlier, we have now kind of captured and pictured smaller compartments that are very equal to each other, so that we can treat them in a right way. Kind of obvious again that will cause a yield increase. How would you approach putting that in numbers?
It's kind of a issue of avoiding the inoptimal management. So there's again a wide range, but of possible values here. If you really, for example, in the boreal zone, if you in the semi-natural forest, if you really kind of time your management activities based on incomplete data or incorrect data, for example, for 3-species mix, you can easily have something like between 10 to 20% yield loss purely from this inoptimal timing of harvest actions. And then, well, it can be pretty much anything. I mean, if you have a very kind of uniform and standardized asset in terms of the yield potential of the sites, then you can reach very good results with this, what I refer by management by the book. But I would say it's very rarely the case. Even if some areas are superficially kind of, yeah, this is homogeneous, this is the same. When you really start to measure 3 by 3, you can see the variation in the executed yield or reached yield. So it's I would say this box it's all about this kind of asset value maximization. You have an asset, you have invested into an asset, then it would make sense to try to get as high a yield out of it as possible, reach the full potential of that asset. And that strongly links to the last point in this box, for example, relieves the pressure on natural forests. So instead of extending the area of the assets, making the most out of what you already have.
Yeah. And I guess predictive analytics in this context, this is where we start applying AI to the mix. And I guess if you have a frequent, accurate inventory cycle, the AI should kind of catch up and be a lot more accurate than, let's say, traditional growth models. When the cycle amount is enough.
Yeah, I mean the kind of the models are static in that sense that they are conditional on the data that the person or who has created the model has had access to at that point of time when the models have been created. So they describe the world as it was when the models were created, and that's one part of a puzzle that needs to be solved because the world is changing. So we need to migrate to a situation where we have the models that describe the basic phenomenon, but then we are also able to adapt to the data that we are getting after applying the models.
Yeah, and I guess those, let's say, traditional mathematic models will still steer as some sort of a benchmark information, but I guess world is moving towards the actual prediction based on the previous growth and conditions.
Yeah. Yes.
Shorter raw material and lead times. Tell me a little bit about the benefits around that.
Yeah, that's the one example, or I would say the prime example of that multiplying effect of and why I don't think the inventory as a kind of a isolated action or isolated event in the whole supply chain, but this kind of a baseline data layer in the whole supply chain digital twin, because then if we are able to predict better the amount of material that is coming from the plant operations to the mill gate, it should logically follow that the mill doesn't need to keep such a big wood yard investment. So the stocking levels at the wood yards could be lowered, and here we are really kind of approaching the topic where we can reap the benefits from that investment all the way back to the baseline inventory, because this is where quite a bit of capital has been tied if you need to, in order to guarantee that the mill has enough raw material to process on continuously. If you need to keep that stock high, then you are really kind of tying your capital into that stock, which could be used more proactively elsewhere.
Right. And something we kind of touched already was the supply chain visibility then, and the, let's say, the ability to optimize that and make more visibility out of that. And then again, in the end, getting lower delivered cost and increased revenue for wood sales. That's where it kind of leads into. So
Yes.
I'm kind of visualizing this as when we talk about why, is like if you start building a business case around this, and let's say whatever the numbers are I think it varies by the companies, but there's a yield improvement. I'm throwing out, let's say 5% because you do this, it should be conservative. You could decrease the damages or prevent them earlier, that's X%. Optimized use of all the chemicals and treatments, one size. Operational improvements on the supply chain, and then yeah, I guess site-specific management gears towards the yield improvement as well. All in sudden, it makes a lot of sense. When you kind of put those numbers together to any let's say substantial forestry operation, it's a big deal. Would you agree?
Yeah, absolutely. Like I said, this kind of a, well, this picture here almost resembles kind of a puzzle or jigsaw puzzle, and that's really kind of one way of looking at that. There are pieces that on their own they bring value, but then when you put them all together, you really see the kind of big picture and have the possibility for the big gains, because they support each other. So if you play the whole game, then that's the benefit is there at the end, which is kind of bigger than the individual parts alone.
Very true. Now let's. I think this is the overall picture that we kind of operating on, but and we're gonna dig into the very details of these aspects on the following webinars. But let's have a short look of a couple of them, starting with the digital inventory, which I think is clear that it's the most critical piece of this puzzle. So traditionally, looking at it, and we kind of discussed, understand the compartment level, and then getting from there to a tree level. I guess the tree level is I like the idea, but I think the ideal today is to get that granular enough site-specific management, right? You should aim to measure every tree, but I think the management starts on that site level. Would you agree?
Yeah, that's right. I think we are pretty far from in reality doing this kind of tree by tree management. I'm not sure that it actually kind of big gains are really there, except for maybe for some very high value tree species where the value of an individual tree is already in thousands of euros. But yeah, I mean that's what happens in here, is that measurement at the highest level possible, but then derive data from that measurement for practical purposes at higher aggregation level.
Right. Yeah, and I think that's good news as far as the, let's say, the overhauling the IT systems, that most of the IT systems are handling kind of compartment level information. It would only be now more accurate and more granular. Then, yeah, aerial images have been quite common in traditional ways, and I think the most accurate way of measuring today would be a LiDAR. LiDAR is very expensive today to use in a forestry environment. However, it's getting more and more, let's say, common. I have a new iPhone. I don't want to brag, but just to mention that it has a LiDAR on it built in. Most of the new cars are using LiDAR technology already, so it gets more common, and I think there is a good signs that within the drone technology sensors, there are some promising new technologies around it, and I think it will be the way of doing it. What would I say? 3 to 5 years from now, I think that's the way to do it. But there's an intermediate step, and this point cloud can be created from the RGB images today, right?
That's correct. Yes. So basically, what we need is a point cloud, and there are alternative ways of arriving at that point cloud. What happens after the point cloud is then from that every tree is kind of modeled from the point cloud. But yeah, it's possible to create a point cloud from stereo photographs. So if you can see the same object from several photographs and you know where the photographs were taken from, you can then do a photogrammetric point cloud from the images themselves. And furthermore, even if we have a LiDAR point cloud is very good for the structural attributes of the trees. But then, especially in northern latitudes, we usually have mixed species forests. And for that, even if you have a LiDAR, you would typically have also a camera for species recognition. This is not so relevant for the plantations where we know exactly already beforehand what species has been planted there. So the structural attributes are what we are really after, but in kind of semi-natural or natural forest cases, also the tree species recognition is one big part of this puzzle.
Right. Do you have any idea? I've been also kind of studying this area, and it seems like the accuracy is if not the same, almost the same as it would be in a LiDAR if you do that from the RGB sensor.
Yeah, it is. It depends a little bit on the structure of the forest canopy, because what we are doing here is we are measuring the trees from up, from the air. So we are looking down at the trees. So what the point cloud describes is the canopy structure of the forest. If the forest is very homogeneous in the vertical dimension, so all the trees are roughly the same size, and it's possible to see the ground in some places, then I would say that they are the one and same thing. You would have the same point cloud from the images as you would have from LiDAR. But then it's a little bit different story if you have a vertical structure in the forest, because the cameras basically they see the top layer of the canopy.
Right. And so point cloud created regardless, and let's say if my assumption is correct that within 3 to 5 years every forest is measured with the LiDAR, going this step, is it kind of the same point? Is it after the measurement, is it the same technology, same way of calculating that point cloud?
Yeah, it is.
Yeah.
It is.
Right. So there is a way to jump into it already. And
exactly.
That's a very good thing. And again, going to the next point, again, it leads to a more accurate kind of a sight around it and the variation within the stands. So again, traditionally, it's been difficult to detect smaller damages and disease and pest damages, for example. How does this technology help on it?
Yeah, for that it is kind of a different ball game, because traditional inventory is a sample, so meaning only part of the trees. Also in traditional inventory, typically you would measure individual trees as well, but only a sample, only a small portion of the total population. The more sample you measure, the more costly it becomes. So you have this typical cost accuracy curves for inventories. This digital forest inventory, it's not a sample, it's an enumeration. So basically all the trees are in the forest are measured, with the caveat of whether all the trees are really visible. But anyway, the most economically important trees are definitely visible because they are the bigger trees. And this means that since we have an enumeration, not a sample, we can pinpoint even a single dead tree in the population. So we really kind of small fractions of the tree populations, they are not the problem. They are counted the same way as all the other trees.
Right. And yeah, one important aspect that I was gonna talk about in the very first picture, but forgot, my bad, but the carbon measurement. How does this make it easier or harder? Very big topic.
Yeah, very kind of hot topic in a couple of last years and getting hotter. Carbon in a tree is one of those structural attributes of the tree. So basically half of the tree biomass is carbon. So if we have each tree more accurately described, then we also have the carbon in the trees more accurately described. However, it's not carbon. When we talk about carbon, it's not only about the trees. Trees are an important aspect of the carbon, but then we also have the organic carbon in soil that goes to the soil because of the trees. So that's another aspect of carbon inventory. But the tree part of carbon inventory is definitely kind of eased by having this kind of digital forest inventory. There's no question about it.
Right. So on potentially your favorite topic around the simulation and optimization, I'll let you talk through this mainly, but yeah, we kind of discussed about how that affects the overall results and how much more accurate that would be. I'd be interested here that, let's say that you make models for, let's say, 5 years forward for the wood flows and everything else. Do you have a data or do you have a understanding of how much that is distorted by the inaccurate source data?
I don't have kind of exact figures to say that okay, this is like it, but okay, what this kind of ballpark figures. The first bullet points here cites that when we model the tree level data, providing data at least 50% better accuracy. So that translates directly into the results, of course. And it also kind of mitigates, like I mentioned earlier, when we then step from just figuring out what is currently there to figuring out what will be there in the future. We have these two sources of uncertainty. One is the data uncertainty, which this alleviates immediately, and then the other one is the modeling uncertainty that is then visible in the results. And the way that works is that usually the predictions, well, if we talk about the Nordic experience with simulation and optimization, up to 5-10 years the accuracy is reasonable, and then it starts to deteriorate quite rapidly after that. So here we come to the time aspect of the inventories. They can work in two ways. Having frequent inventories means that you don't, for certain planning purposes, you don't need to go beyond the comfort zone of the models. So you can stick to the 5-year planning horizon, for example. Again, of course, for the long-term projections, this kind of strategic planning where you really look at the long time frame and see whether the utilization of forest resources is sustainable over long term, for example, then you simply have to go longer in time. But here we can then come back again to the topic of this predictive analytics and learning analytics, and trying to improve or reduce the uncertainty in the models that way.
Very true. Mindful of time, and we have a lot of exciting topics around this. So we start with digital inventory, where we're going to dig into in the next webinar, looking at different technologies and possibilities, which we kind of touched today, but also in the supply chain visibility, a lot more detail on optimization and simulation, and the whole package. So hopefully this created and painted the picture of the overall smart forestry offering and how we approach things, and looking forward to see you in our next webinar. Please send any potential questions, or you can contact us. You can see our contact details here at any given time, and we'll get back to you as soon as humanly possible. And we've had quite a few questions, which we will also address in the LinkedIn channel, but also directly where we know who to approach. And yes, like I said, please be in contact if you have any additional questions. Thank you so much for attending. I'm very pleased to see that there's so many of you, and looking forward to see you next time.
Yeah, absolutely. Looking forward to the continuation of these seminars and really kind of digging deeper in these topics that we touched upon today. So hopefully meet you in the next webinar of the series.